Wow, it quieted down quickly in here. I'm Kelly Cryderman. I'm a reporter and columnist for the Globe and Mail, and we're having a session on hydrogen. And we've left the parameters kind of open because we have three experts here today, and I don't say that lightly, to talk about it. And first, right to my side, we have Michelle George, who is the Vice President, New Energy Technologies at Enbridge, and she focuses on advancing low carbon infrastructure anywhere in Enbridge, and in terms of hydrogen, CCUS, and other low carbon technologies. And then we have Kyle Mulligan, who is the Assistant Vice President, Operations Technology at Canadian Pacific, but basically he's the hydrogen train guy, he tells me, so which is very cool. And next to him, we have Justin Riemer, who's the Chief Executive Officer of Emissions Reduction Alberta, which is a arm's-length provincial body that has used about $800 million in the last 12 years from heavy emitters to fund low-emission technologies in the province, which is also very cool. And this is our discussion today. And, you know, one of those things when I cover energy and politics, a lot of people ask me about hydrogen. They don't understand that much, and I know this is a well-informed crowd, but one thing I wanted to ask all the panelists is when they're talking to a neighbor or a family member about the potential for hydrogen, what do you tell them? And if you could also explain a little bit about your job in that as you give that explanation, that would be great. Michelle?
Sure, you know, it's a great question, and I will say I get asked this a lot because I have spent my whole career at Enbridge for, I've been doing it for about 27 years, spent a lot of time on the natural gas side, and so people get that. And now I talk about new energy, and they're like, what is that? So I will start with Enbridge is, you know, at Enbridge we're in the infrastructure business. We have pipelines, we're utilities, renewables. We've been doing renewables for about 20 years, and now we're moving into low carbon as well. As you said, Vice President of New Energy Technology, so we focus on advancing those low carbon solutions across all of the businesses. Our strategy, though, is to deliver the energy that we need today. So that's secure, affordable, and sustainable energy, while investing in the transition to be able to deliver the energy for tomorrow. And that, to us, I feel very strongly, it includes all forms of energy. So it's more renewables, it's cleaner oil and gas, and it includes hydrogen, renewable natural gas, carbon capture, and sequestration. So moving on to I should also mention, all of that will support us meeting our net zero targets for 2050. So hydrogen, to me, in the panel was called a decarbonization hero. And I do think it is a hero. It has some superpowers that I want to talk about, but it's not the only hero, as I said. So it's kind of like for the Avengers, we need all of them, not just Iron Man or Captain Marvel. I had to get my daughter to give me those references. So hydrogen superpowers, it has the ability to reduce emissions in hard-to-abate industries. So those high-heat industries like steel and cement, it can reduce emissions there. It can provide longer range for transportation, so that planes, trains, and trucks, and we're going to hear a lot about trains, which I'm excited about. And it also is a great energy carrier and great for energy storage. So it can help stabilize the electricity grid. It can connect the electricity and natural gas distribution grids. It can also be used to lower carbon emissions in building heat. So blended with natural gas, it can reduce emissions. And it also can provide that baseload power, and baseload and peak power that really then supports renewable development. So, so that's generally how I explain the superpowers of hydrogen.
All right, perfect. Well, thank you. Well, first of all, any of you who know railroaders know that railroaders always talk about the railway. And typically, when people come over to our house, I get like 1 hour to talk about railroad, and then my wife gets upset. So, but, the discussion, it's essentially what I do for the railroad is I'm in charge of the hydrogen locomotive program. And in October of 2020, CP decided to start a journey to convert diesel electric locomotives into hydrogen electric hybrid locomotives. The reason why we wanted to do that is we burn about $1 billion worth of diesel fuel per year. It's our most expensive cost, and our second most expensive cost are the people that that operate the business. So, essentially, as climate change continues to evolve, economic headwinds due to carbon taxes, that will eventually affect our ability to operate. And so investing in zero emission technologies is something that we're looking to do. So when folks come over and they talk about railroads and locomotives and the hydrogen program, there's no end to what you can talk about. What makes locomotives excellent platforms to convert is that you can take the diesel generator and alternator out, and you can put these zero emissions technologies in to power the already existing electric traction motors. So they're already hybrids to begin with, and one of the main things that we can do is just pull the dirty components out and put the clean ones in. And then secondly, the other thing that comes up around the dinner table is infrastructure. And, thanks to help from the ERA, we are currently in the process of expanding with one electrolyzer here in Calgary that'll be powered off of CP's 5 megawatt solar farm in our head office. So we're aiming to generate green hydrogen, and then we're going to be installing a second electrolyzer in Edmonton so that we can operate trains between Calgary and Edmonton and really prove out the zero emission technology concept as we look to expand across the country.
And yeah, Justin, please.
So Justin Riemer, CEO Emissions Reduction Alberta, really pleased to be here today. So we invest in technologies to de-risk them, and we've been doing this for over a decade. As Kelly mentioned, over $830 million worth of investments. We've had the privilege and honor of investing in Kyle's train project and the hydrogen train. What Kyle didn't mention is the train's quiet. Very quiet, which is like a Tesla on rails, which is kind of cool. And so we believe hydrogen is a hero, but it is not the only silver bullet to get us to net zero. So it really needs to be viewed in the scope and portfolio of a range of different options that are going to get us to that net zero future. Alberta has some major structural advantages to the hydrogen economy. If you're going to do the hydrogen economy in Canada, you're going to start in Alberta. We make it very cost competitively here, and we have a lot of the existing skills, expertise, infrastructure, and know-how. A bunch of supply coming on stream. We're really looking at the demand center, and we'll get into that in a little bit. But as Michelle said, there's a range of different things that can be used with hydrogen fuel sources now, and we're investing in a variety of them to demo them. Buses, trains, heavy vehicle fleets, semi-trucks, heating homes with a small percentage of hydrogen going through the natural gas lines. We're actually funding a demonstration with ATCO right now to fund 20% of hydrogen and natural gas lines in Edmonton to heat 11,000 homes and businesses. So there's a variety of different opportunities in the hydrogen economy. You just have to put it in perspective. It's not going to solve all of our issues, but there are some really interesting opportunities.
And I want to go off Justin's comment there. Kyle, you were with the train this morning in Calgary. Tell us about that.
Yeah, so we do test the locomotive twice a week, and I'd say when you take on a project like this, you need to make sure that the team that you've equipped yourself with wear many hats. And one thing that we do at Canadian Pacific, including all the way up to the assistant vice president level, is that if you're healthy and capable, you are basically trained to operate trains, and you're deployed to run the business. So one thing that I think, obviously when we started this project, we went and we engaged with the OEMs. So there's two big OEMs in North America that support the North American rail industry. And, they just did not have an aggressive enough roadmap to support the needs of CP, but the needs of our country as well and our climate goals. So when we approached this project and decided to internalize this, one of the strengths that we have is that people, including myself, can operate the locomotive. So when we test twice a week here in Calgary, it's the same team that's building the locomotive that's actually operating and testing it. And in terms of the experience, the locomotive is virtually quiet, so you're welcome, Inglewood. Alyth Terminal will no longer bother you with load testing at night. And it, for all intents and purposes, though, the actual locomotive itself operates exactly like a diesel-electric locomotive does today. So that's what makes this even more compelling from a technology perspective and an integration perspective at CP.
And I know there's a safety concern with EVs being too quiet. Is there a safety concern with the train even being too quiet?
You know, interestingly enough, in a train terminal, you know, we always say to our employees, keep your head on a swivel, because even a freight car, a loaded tank car, can go by you in the middle of the night when it's dark and you won't even hear it. So in terms of our operating rules and our safety protocols, the fact that the locomotive is silent doesn't change how we have to operate today.
Okay, and Michelle, I want to talk to you about the projects that are interesting to you. Like, when you point to something that's very cool and coming up, what do you point to? What are the possibilities? What are the challenges? Because we know it's not a straight shot to any kind of commercialization or everyday implementation of technology, of hydrogen technology.
Yeah, great. I love talking about our hydrogen projects, so happy to do that. Enbridge was really an early mover in the space. So I'm going to focus on sort of three areas. One is green hydrogen, blue hydrogen, and then hubs as well. So green hydrogen, we were an early mover there. We built the first utility scale power to gas green hydrogen plant in 2018, and that's in Markham, Ontario, and it's a 2.5 megawatt electrolyzer that makes about 1,000 kilograms a day. And it was originally built to help stabilize the electricity grid. There's a lot of renewables in Ontario, and they needed some storage and stabilization support. So we came up with this concept of using a hydrogen plant to do that. But then as of last year, we're now blending into our active distribution system. So similar to what ATCO's looking at, we are blending into a small area near Markham, about 4,000 customers. It's a small amount. We're the first in North America to do that. And being first is always fun and exciting and also has its challenges. So, you know, navigating the regulatory and permitting environment, trying to come up with commercial models for it, and then assessing the existing assets as well as designing the new ones were some of the interesting learnings that we had. But we are applying those learnings to our utility in Quebec, Gaz et Fer, and they're going to be blending into the entire system there, which is to about 45,000 customers. So we're looking to blend more from a bigger plant for that project. And I will say, I think learning a lot is probably a theme of all hydrogen projects right now, and it's great the way I think the industry is sharing that. So blue hydrogen, just quickly, our Enbridge Ingleside Energy Center in Corpus Christi, Texas, is an oil export terminal. It's VLCC capable, and it is in a great location. And we are greening our own grid there by building a 60 megawatt solar facility to self-power and also to sell back to the grid. But we're also developing a blue hydrogen plant there, and it's really well located because it is near a lot of natural gas facilities, including our own Texas Eastern natural gas pipeline, and you know, its location is really good for export. And we've had a lot of interest in export, so the good thing about blue hydrogen, you can build at scale fairly quickly, and a lot of interest from Europe and from Asia for offtake from there. And then I wanted to touch on hubs because I think hydrogen hubs is a way that hydrogen is getting developed in North America, and they provide a great opportunity for partnerships. And this is one of the unique things I think about the low carbon space in the energy industry is we're seeing a lot of interest and willingness to partner, whether it's with, you know, typical competitors or other strategic partners or with technology companies or, and most importantly, with stakeholders. So this is a great opportunity for Indigenous reconciliation and Indigenous partnerships on hydrogen hubs. And so I can cover, maybe I'll cover just a few challenges. I think there's lots of great opportunities we're talking about. There are a few challenges. I'll start with cost. So it does cost more. And so that means it's less competitive with, you know, existing hydrogen. In North America, we produce about, I think, 13 million tons of hydrogen, 10 in the US, 3 in Canada. And it's more expensive to decarbonize our energy. Anyone who tells you that it's not is probably living in the Marvel universe. So, you know, how do we get there? We need support, government support, whether subsidies or incentives. And we've made some good progress from a policy perspective, but we still have a ways to go around that. Permitting is the second one, so policy helps, but no one's going to invest in energy infrastructure if you can't build it. And it is very difficult to build energy infrastructure, whether it's low carbon or conventional energy infrastructure in Canada right now and in the US. And so really we need some predictability, we need certainty, we need an inclusive process in order to get these facilities built. And then the last one is technical. So, there's a lot of technology available. I don't want to overstate the technical challenges, but we're using either new technology or using it in new ways. And so that takes innovation and patience because it takes a little bit longer than you'd like.
Okay, and Justin, I wanted to ask you, when you talk about the projects that emissions reduction Alberta is doing, what are the ones that are the most advanced, the most interesting?
Sure.
The ones that people want to talk about?
Yeah. So mentioned a couple up the top, but we've invested over $50 million in hydrogen projects over the past 10 years. Probably the most notable one on the upstream side is Air Products hydrogen plant with carbon capture. This is a $1 billion facility, so we're just a small contributor to it, but federal government's investing and others. And this will be I believe the first fully integrated large hydrogen production facility with carbon capture integrated into it, and expected to be operational within the next 2 to 3 years. So that's going to put a lot of additional hydrogen supply in the Alberta industrial heartland market. And when we talk about hydrogen hubs, that's a significant hydrogen hub within Alberta. We've been involved in the creation of a consortium of support, if you will, from both federal, provincial, municipal governments and industry and academics working together to understand the base case for not only production and supply of hydrogen, but the demand and the utility. I talked about the ATCO trial where we're heating around 11,000 homes with a partial supply of hydrogen into the natural gas lines. And then on the downstream side, very pleased with the train. I think that's the coolest project around. But also supporting hydrogen buses. So there's an event in Edmonton this week where they'll be deploying a new fleet of hydrogen buses, and we're happy to support that. What's really interesting is the conversion of semi-trucks and fleets into hydrogen or dual fuel. And there was a big hydrogen conference in Edmonton not that long ago where some of those trucks were deployed. What's really fascinating is there's a lot of challenges to seeing this fuel conversion. Like Suncor just can't wake up one day and decide I'm going to put hydrogen fueling stations in my retail gas outlets and trucks will start to come and fuel. There needs to be a consortium approach of energy, oil and gas firms, pipeline transportation, trucking firms, trucking manufacturing firms, and then government working together on the permitting and so forth. So there's a lot of work going on behind the scenes right now to enable sort of the testing and trial of heavy vehicles and trialing semi-trucks going from Edmonton to Calgary using dual fuel or pure hydrogen. And that's going to be a bit of a test case. We need to get that infrastructure established for this really to take off in the long term. So those are a couple of the projects.
So interesting. And, I was listening to an interview with the federal natural resources minister, Jonathan Wilkinson. He's one of the few people who actually has a hydrogen vehicle. And I need to know the story for how that fueling takes place,
Yes,
right?
yes. I'm not sure where he's getting that from.
Yeah.
Yeah.
And Kyle, you talked about being able to switch out parts in a train, diesel for hydrogen. But what are the challenges that you're facing that maybe you never thought of or that no one would think of in developing? What is a new technology and where does it stand in terms of the development of hydrogen trains in North America and the rest of the world?
Okay, good question. So in terms of where I'd say the challenges have been in the technology, it's mainly around the power electronics. So what you'll hear about a lot of battery electric stuff out there, and what they do when you try to tie all these components together, they typically require very high voltages on the main bus to power your traction motors, your auxiliaries, and all of those other things. So in the heavy haul industry, you're operating at much higher voltages than the automotive industry. And when we've seen applications of battery electric, as an example, locomotives, all they're doing is stringing a whole bunch of batteries together to get to the voltages that they require. But when you start getting into battery fuel cell or power blending, you need DC to DC converters and you need inverters, and they all have to operate at 1500 volts and above. And so, we have been working mainly with European vendors to be able to get that technology, and we've had to. What we do mainly at CP as the integrator is the control system is our sort of brainchild. And so by further innovating in that space, we've been able to get the power requirements that we need to operate a locomotive. But we were very surprised to see that in North America, the technology that we have here is probably about a decade behind what they're doing in Europe. And so, I think, fortunately we were able to get the components that we needed, but we weren't expecting to look across the ocean to do that.
What is the timeline for serious adoption of hydrogen in everyday, in some kind of hub or everyday use in Alberta? Do you see, and is it a transition fuel, or is it something that's going to be around for decades and decades and decades?
Yeah, that's a $1 trillion question right there. So there's a number of countries out there that now have hydrogen strategies. The federal government has been working on one. The provincial government of Alberta recently released one this past year, and trying to work together and anticipate not only on the supply side and the technology side, but the demand side. And the demand side is ever changing and going to be influenced significantly by the Inflation Reduction Act. So I don't think it's quite clear yet what the ultimate utilization is. There's so much to be done yet on this technology deployment in trains and vehicles and other things to really get a better, accurate description of what the full market demand will be. The bulk of our hydrogen is still used for processing and refining in heavy industrial. I think there'll be a lot of adoption in the heavy industrial use as big industrial emitters switch to using hydrogen fuel for a portion of their fueling needs to get themselves closer to net zero. But I think one of the big questions for Alberta in particular is, are we going to have export potential for hydrogen? So we're focusing first on domestic demand in terms of the vehicles, in terms of the home heating, in terms of industrial use. It's not easy to ship hydrogen long distances. There's lots of different alternatives being looked at, including shipping it via ammonia overseas, and there's lots of interest from Asia in our ammonia and being able to ship that. That's not an easy thing if you think of large amounts of unit trains of ammonia moving to the coast. There's opportunities to blend hydrogen in existing natural gas lines, not fully because as Michelle could tell you, there's all kinds of issues there, but there's a lot to be done yet in terms of both the supply, technology and market creation and the demand side. And I think costs are going to have to go down markedly for it to become much more competitive and readily adopted and become a much bigger user into the future. So.
And of course, Alberta is known for being an oil and natural gas province. Does the development of a hydrogen industry in the province that people know about that is somewhat available at the retail level or is visual to people, does that allow the province to bust up some stereotypes about its focus when it comes to energy?
Yeah, it absolutely does. This is the beautiful thing about hydrogen and why Alberta is a great place to do it, because it's not much to pivot with our existing infrastructure, our pipelines, our energy expertise, our refining capacity, and move into the hydrogen economy. It already largely exists here. So it's a great way to utilize the talent and expertise and ingenuity that Alberta already has in that infrastructure and provide a cleaner, greener source of fuel into the future. So I think it's a must-do for Alberta. Again, it's not the silver bullet. It's not the only thing we need to be doing. But that hydrogen and carbon capture utilization are probably two of the biggest things Alberta can focus its energy sector on, not only for deployment in our own domestic use and net zero, but think about the value chain and supply chain opportunities and creating a new industry where we can begin manufacturing again and exporting all over the world our skills, expertise, and manufacturing equipment like we did for oil and gas. There's no reason we can't ride a second wave into the net zero world with hydrogen and carbon capture into the future. The world is buying it, is needing it, is developing all kinds of incentives. So but we can't sit back. The U.S. is now more competitive than we are with the introduction of the U.S. Inflation Reduction Act. We were the first jurisdiction in North America to put a price on carbon 12 years ago, but we can't rest on those laurels. We have to continue on a government regulatory side to match the competitiveness of the U.S. and others to take advantage of this opportunity.
And Kyle, this is a total layperson's question, but I have to ask you, you talked about getting your supplies from European firms. Is there any complication with the vast distances we have in Canada versus European trains? Is that a complication for hydrogen at all?
Yeah, well, for us, essentially, the hydrogen locomotive gets about a fifth of the range of a diesel-powered locomotive. So, that's basically pushed us towards having a tender car to carry extra hydrogen. Now, there are going to be technologies around hydrogen liquefaction that we can eventually leverage. But the issue is if we jump to those technologies, we're just going to sit for 5 more years. So we did the conversion. We're building a tender car. We're going to actually build a few more units and power them in our bulk trains moving bulk commodities to the West Coast. And then, the business case for us to move to liquefied hydrogen and those things will be to eliminate the tender car and then just continue to get incrementally better. The other issue we have really around supply chain is, ironically, it's not the fuel cells and it's not the power electronics, it's the batteries. So, with fuel cells, you can pretty much do, a 70% fuel cell is, that's where you're deriving 70% of your power from, 30% from the batteries. But batteries, they get built, you either source them from China or you source them from Germany, and when they ship them, they have to be shipped on a barge. And so just that whole supply chain from when the batteries are manufactured to when you actually receive them can easily take 2 months. The other part around batteries that's challenging is just what do you do with the battery once it's not good anymore? And what's cool about fuel cells is that 90% of the fuel cell membrane, so it's platinum and graphite, is not only recyclable, but it's recyclable right here in Canada. So, our design, so challenges in supply, but also reinforcing, in our view, the need to be heavier on the hydrogen side and lighter on the battery side.
And do you have a date for when this could be running between here and Vancouver or anything like that? Or is there an end goal like that? A public end goal?
Oh, yeah. Our first movement between Calgary and Red Deer is going to be 3rd week of October, so next month. It'll be a light engine movement, and then the train coming back, it'll be actual freight hooked onto it. We're switching in the terminals today. And then our second locomotive is going to be finished in a month, our third locomotive Q2 of next year, and we're looking to expand that with more locomotives. So our time frame to fully prove this out operationally, all seasons through mountain grades, is end of 2026.
And I am aware of the time, and I want to leave a little bit of time for audience questions, but I want to ask one final question to you all, starting with Michelle to answer. And we talk about hydrogen in the context of net zero goals and as a carbon hero. But is there a energy security element to hydrogen right now too? We're all talking about that. We're all thinking about that as well. Is there an element for that for hydrogen?
Oh, yeah, I think there absolutely is. So hydrogen is a very flexible fuel. So to build on my other analogy, it's like the mom in The Incredibles, which I know is not an Avenger. She's my favorite character, though. But it's a very flexible fuel. It also ties to our natural gas system, and it can effectively create an ability to export renewable power. So I think all of that flexibility around it helps with the energy security. But like taking a step back and overall, for me, this ties back to the all of the above approach. We need it all, and we need it now. And so, we need to be able to address climate and provide the increasing demand for energy. And I think hydrogen is absolutely part of that, and that includes security.
Yeah, I think for us, absolutely, we burn, as I said, diesel fuel, and ultimately we're sensitive to the fluctuations and ultimately the global impact of those prices. So our ability to operate, our ability to deliver quarterly results is directly related to those types of global impacts. So the more we can do to diversify our fuel source, the better off that we're going to be.
And Justin.
I'd echo my colleagues' comments. I guess I would think of it from a provincial security perspective. Alberta knows hydrocarbons and does hydrocarbons very well. And I can't imagine a net zero future without some element of hydrogen development utilizing our vast infrastructure. There's a dedicated hydrogen pipeline in Alberta's industrial heartland that's been in place for over a decade now. You just think about the opportunities to build off of that and see other forms of demand and utilization into the future. It's exciting.
Okay, and I do want to open it up to the floor to see if there's any questions. There's questions, good. Let's go over here.
Thank you very much. Fantastic discussion. My question is for you, Michelle, and it's really around the cost of hydrogen. You touched a little bit on it, on the tax credit that enables a lot of the bill to happen. I want to understand your thinking or what you believe the role of carbon markets and carbon credits could do to scale up the market for hydrogen.
Well, having carbon markets or a global price on carbon obviously would make things a lot easier and would certainly would enable the demand and then drive out the market development based on and this kind of comes back to the all of the above approach. It would enable the market development based on reducing the most emissions for in the most efficient way.
Does that answer your question? Yeah.
Hi, thank you for the discussion. I don't think I heard anyone mention water considerations across the different spectrum of hydrogen colors. Could you comment on that and whether there's any possible solutions that are being thought through?
So, the color, we didn't really get into the color, so it is a great question. I only talked about green and blue. Between those, blue is, this is the thing about hydrogen. The carbon intensity really is based on the energy used to separate the hydrogen as an element which does not exist by itself on Earth from whatever molecule it's part of. So for green hydrogen, it is separating water into its base elements of hydrogen and oxygen. So that would need to be a consideration, and it's using electrolysis. So it uses electricity to do that, which again, you need to have renewable electricity for it to be green hydrogen. And so I feel like I'm repeating myself. I'm not intending to, but this comes back to the all of the above. What works best in different geographies and jurisdictions depends on what is available. So what is available in order to create the energy that we need in order to serve all of our energy demands. So where there is, abundant water, that would make a difference compared to, and this is part of why I believe in North America there'll be a lot more development of blue hydrogen, because natural gas is the feed for blue hydrogen, and there is abundant low-cost natural gas in North America that will drive that development, which is also clean hydrogen, and it can be very, very close to zero emissions with blue hydrogen, and I think it'll get there fairly quickly from a technology perspective. So you really need to consider all of the inputs, including land use and also the transportation to get the energy to where you need it.
Do you have anything to add there, Justin, on blue versus green? No.
I'm going to put Justin in a little bit of an uncomfortable seat, and I apologize.
Great, thank you. What's your name?
Justin as well, so it's actually perfect. Huge fan of the ERA, so I apologize ahead of time. Federal and provincial governments have been very focused on CapEx incentives, while Inflation Reduction Act is now changing the fundamentals of some of these clean techs.
Yes.
Do we think that the CapEx version is still the appropriate, or is there a time and place to switch over to helping the fundamentals of projects and helping them be adopted.
And in thinking more consumer and incentive demand structure. Yeah, I think there's thousands of bureaucrats working away on analysis and proposals right now federally and across the provinces to determine the implications of the Inflation Reduction Act and how Canada may or may not need to adjust some of its policy and incentive infrastructure. There's been a lot of announcements, both provincially and I'd say more federally, over the past couple of years, and a lot of funding being allocated to tech development and incentives, more on that supply side. I would say a good majority of that funding has not flowed yet. And so there's a lot of stuff in the pipeline. There's a lot of applications. We're waiting to see what the implications of some of that funding are to challenge the structure. But I fear governments often don't react quickly enough to market forces, right? And I can say this because I worked for government for 25 years. So we have to change the way we look at policy incentives. And I think the market forces are going to require us to adjust our policies much more quickly, but that's always complicated by politics, right? So it's a very good question. I don't know what the answer is, but I think we're going to not have to look too long to our neighbors to the south to see what sorts of investments are being made down there that will hopefully get us to respond quickly.
I should have sat closer if I knew I would ask a question. So the panel represents almost a perfect partnership for scaling up hydrogen. So you have end user, you have producer, you have strategic investor. In your view, what are the main obstacles and opportunities for partnerships? And I'm more interested on like human element of building partnerships for scaling up hydrogen projects.
I can start if you like. I think of it in terms of projects. So I talked about the conversion of heavy vehicle fleets and semi-trailers conversion. There's a lot of technology out there waiting to go, but there's not necessarily a ready market to have them deployed and utilized. There's emergence of some in the U.S. and like a test hub in Alberta. And I think it's going to require some strategic leadership on the part of government and industry to work together to have the refiners, the truck manufacturers, the truck distribution lines, as well as the government regulatory folks. In Alberta, we have the AMTA, Alberta Motor Transport Association, that's been providing a lot of leadership and demoing vehicles in this opportunity. But you're herding cats, and you have to herd a lot of these cats in the same direction and understand everyone's mutual goals, drivers, and business objectives, and try and find ways in which government incentives can fill the gaps that exist, but let market forces be whole. But I think it's very different for that, say, than the deployment of a green hydrogen electrolysis unit for electricity generation, right? So it really depends on the project. Michelle.
Oh, yeah, well, I think I can just tell just from the end user off-taker, like we are obviously working with oil and gas to set up the electrolyzers and those companies, but generally what they tend to be interested in is like the big picture, the national infrastructure plan. And the thing with your transport off-takers, you know, we're more incremental type businesses. You know, we're capital intense, so the question about what should the government be doing? We love the capital matching type grants. We're a capital intensive business, and we're not interested in long-term loans because we can get those from other sources. But we do things in an incremental way. So we'll build one locomotive, we'll build 3, and then we'll go 4, and then we'll do 12 and 20 and 200. But when we talk to oil and gas, they're like, no, we want to do all the way across the country. We want to do everything all at once, and that scares the executive
Where's the
team.
scale?
Right. So I think we have to be cognizant when we build this out, and the national infrastructure plan and governments or what have you need to be cognizant that this needs to be an incremental approach, and it needs to be an approach that makes sense. And the way that all these sort of incentive programs are structured, it's who's asking for the most money and who's going to have the biggest carbon reduction with that money. And that doesn't work for transportation. And that's what the ERA recognized with us. It's building for the future. It's not, what's that quick win that I can get now? Because it doesn't exist. So there you go.
I'm just going to add one thing, because I did talk about partnerships to start, and I'll just say, you asked about challenge. There's lots of interest and willingness in partnering, and I think it's leading to a lot of non-traditional partnerships, and the biggest challenge there is culture. And so as you're highlighting, different companies, big companies can be very difficult to get decisions made in sometimes, and especially when you're working with new technology where they're used to moving really quickly, or so it really is about aligning your goals and setting those aligned goals and focus areas, I think, to drive effective partnerships. But lots of interest, and it can be challenging too.
Thank you very much. I just have I'm not from your sector, so this is a super beginner question. But in the IT sector, there's one company, TSMC in Taiwan, that has 90% of the market for the most advanced chips. And there's one company in Holland that has 100% of the market for the technology for that company. I'm wondering, is there any risk in the hydrogen technology sector, of one or two companies in one or two countries dominating the technology and getting the technology breakthroughs that would affect your sector?
Yeah, I can definitely speak on the power electronics and the battery side. I constantly hear, oh, Texas Instruments doesn't have enough chips for us, So I do think that introduces quite a bit of a risk. And I think that different announcements about ensuring that there's a certain percentage of chips that are fabricated in Europe or North America versus offshore is definitely required as this technology scales up. Otherwise, it does present a huge risk in terms of us achieving our goals.
Anybody else? Can we push it a bit on the questions, or are we right out of time? We can do one more. Let's do one more question. Oh dear, there's two more questions. Who was first? Okay. I'm going to take your word for it.
She was.
Yeah, okay. Sorry.
So, looking farther into the future, you're designing these trains now, these locomotives now. You are investing in new tech now, and I'm wondering how much consideration is being given to that design in terms of circular economy, in terms of, are we designing these things so we can take them apart easily, so that the parts that come apart we can recycle easily? That's my question.
I love this question. It's great. So actually, I think that attests to the power of building this in Alberta. So we, half the locomotive is like a miniature oil and gas plant, it looks like, and then the rest is locomotive. And what we've been able to do is really take that concept here in Alberta of, skids that they'll use in the oil and gas industry. So all of our power electronics, fuel cells, batteries, you name it, they mount onto a skid that gets manufactured on a production floor, so you don't even need the locomotive to be there. And why that's important is that skid, when you look down the side of a locomotive, it's all full of doors the whole way. So all of those components are removable. And what we're looking to do is basically 3 levels of maintenance. So the existing maintenance that we do on locomotives today are going to be done by our running trades folks that are in the shops today. Then there's going to be a level 2 where we can actually pull the component out and just swap the component. But then our level 3 is really, now we need to dissect that component, repair it, and then get it back into service. On the battery side, we haven't quite figured that out yet because we're still in the prototype stage. They are modular components that come out of the locomotive, and everything on the unit is maintainable. But definitely we have figured out the fuel cell side working with Ballard in terms of recycling those membranes and then doing that maintenance. So long term, we do want to have a center of excellence here in terms of the maintainability aspect so that we don't have to take this giant fuel cell, ship it somewhere, get it fixed and get it back. We want to be able to do that in-house. So
there's a company in Calgary called Xro, and they're a startup, and they have a way of monitoring every single cell separately in those battery packs so that you can pluck it out and drop in a new one so that you don't have to trash the whole battery recycle little bits at a time to renew it, right? So I just
Yeah.
wanted you to be aware of that.
Thank you. Yeah, appreciate that.
Anything to add? Well, we've gone over time already, and I want to thank Justin, Kyle, and Michelle for all their insights. I learned a lot. Things are more advanced in a lot of ways than I thought, and for the better and excellent questions from the audience, too. So thank you so much.
Thank you.